Solar rotation and Earth's energy balance. Solar rotation, often the solar resource or just sunlight, is the general term of the electromagnetic radiation emitted by the sun. Solar radiation can be captured and turned into useful forms such as heat and electricity, using a variety of technologies. However, the technical feasibility and economical operation of these technologies at a specific location depends on the available solar resource. So we have here the Sun. The Sun has a diameter of 1.39 E9m, or should I say 120 times greater than the Earth. The Sun provides by hydrogen fusion. It is also composed of layers, and the outer layer is the photosphere. Sun effective back body temperature is about 5,777 Kelvin. A solar radiation is a radiation energy from the sun, so it provides light and heat for the earth and energy for the photosynthesis. This radiant energy is necessary for the metabolism of the environment and its habitat. There are three things happens to sun's energy when it enters Earth's surface. The first one is absorbed, reflected, and scattered. Absorption is different from scattering and reflection because absorption involves more than a change in the direction of the radiation. Absorption of radiation involves the conversion of electromagnetic radiation into heat energy. Reflection of solar radiation occurs when the radiation is sent directly backward from a surface. The fraction or a percentage of radiation reflected back is known as albedo. Albedo varies greatly from one location to another on Earth depending on the type of surface, or for example, land or water. Okay. Scattering. Scattering of solar radiation occurs when the radiation strikes very small objects in Earth's atmosphere, such as air molecules and aerosols. Scattering in the atmosphere. Air molecules are much smaller than the wavelength of light or scattered than the red, longer wavelength of lights. This is the reason why the sky appears blue during the daytime. Water droplets and ice crystals that makes clouds scatter light equally at all wavelengths and therefore appears white. The solar radiation, called the solar resource or just sunlight, is a general term of the electromagnetic radiation emitted by the sun. 69% of incoming solar radiation is absorbed by atmosphere and Earth. What is the role of solar radiation? The role of solar radiation provides heat, light, and energy necessary for all living organisms. Infrared radiation supplies heat to all habitats on land and the water. And how does it impact the Earth? The energy emitted by the sun through electromagnetic waves and life on Earth depends on it. The greenhouse effects. There's sun, clouds, rains, and a vapor. Water vapor or aqueous vapor is the gaseous phase of a Earth's energy balance. You have learned the Earth's surface and emits radiation at the same rate. This balance in the rate of Earth's absorption and emission occurs at 255 Kelvin. This difference can be explained when you take into consideration the atmosphere. This difference can be explained when you take into consideration the atmosphere. Even though Earth's atmosphere absorbs some wavelengths of radiation, or the transferring their energy into heat, while other gases are transparent and allow radiation to pass through freely without absorption taking place. We have here the Earth's energy balance diagram. Energy entering top of atmosphere is equals to energy leaving top of atmosphere. So we have here 342 mo na siya ang top of atmosphere entering the top of atmosphere is equals to 107 plus 235. And energy gained by atmosphere is equal to energy lost by atmosphere. The gain by atmosphere is 67 plus 350 plus 78 plus 24. And then the energy lost by atmosphere is 165 plus 324 plus 30. The energy entering Earth's surface is equal to energy leaving Earth's surface. We have 168 plus 324 is equal to 24 plus 78 plus 390. Okay, the overall energy balance of the Earth is influenced by the reflective property on the surface, or the albedo, as well as by the ability of atmospheric components to interact with infrared radiation emitted from Earth's surface, or the greenhouse effect, with both processes being strongly coupled. To sum it up, all the energy that the sun gives, it goes directly to our Earth's surface, but it is divided into two because the 70% of it goes to our Earth's surface and the 30% of it are reflected to our space.